Hi everyone, I'm Roy. Welcome to the first episode of our series on real EWRB exam result reports. In this series, we'll analyze actual results at different levels, 90, 80, 70, 60 and 50 marks, and see what students can learn to improve their study. Today we're looking at a real candidate who scored 90% in the electrician theory exam. It's a strong pass, but the knowledge deficiency report shows 10 wrong answers out of 90. That's a bit strange because 80 out of 90 works out to 88.9%, not 90. Anyway, let's see where those mistakes happened and what we can learn from them. Next, let's look at the 10 error topics. They are safety tags, correct placement and removal, switchboards, main, men and distribution requirements, test instruments, how to connect them properly, installation testing, methods and limits under AS/NZS 3000, three-phase motors, using capacitors for power factor correction, reduced voltage starters, different types and their uses, single-phase motors, split-phase and capacitor types, alternators, basic construction, lighting principles of common lamp types, fluorescent fittings, common faults and how to fix them. We'll go through each of these one by one in the next slides. Let's look at 14.2F, safety tags, placement and removal. The placement rule is clear. Danger tags go on all points of isolation to protect people and must show the worker's details. Out of service tags go on faulty or unsafe equipment to stop operation. So in short, danger tag, don't touch, my life is at risk, personal safety. Out of service tag, don't touch, this equipment is faulty, equipment safety. Now let's look at safety tags removal rules. A danger tag must not be removed except by the person who placed it, or under an approved removal procedure. An out-of-service or warning tag may only be removed by a competent person who has confirmed the equipment is safe to operate. Common exam mistakes include thinking anyone can remove a tag, failing to record details, or using tags alone without lockout devices. Next, let's look at 17B, switchboards. The common exam mistakes include forgetting signage, thinking more than one men link is allowed, or ignoring access clearance. Suggestion: always bring AS/NZS 3000 and the electricity safety regulations into your theory exam. They're allowed, and you'll find the detailed switchboard requirements in these references. Next, let's look at 19B, test instruments. This is general knowledge about how instruments are connected to test a circuit. Exam mistakes often come from careless reading, or because the wording of the question is tricky and not very clear. Next, let's look at 20D, the minimum and maximum values, where appropriate, that are acceptable for testing installations. For RCD testing, the rule is clear. Both AS/NZS 3000 and AS/NZS 3760 set strict performance limits. At half-rated current, the RCD must not trip. For Type 1 10 mA RCDs, the trip must be within 40 milliseconds. For Type 2 30 mA, the trip must be within 300 milliseconds at rated, and within 40 milliseconds at 5 times rated. Next, let's look at insulation resistance results. The rule is clear. The insulation resistance must be at least 1 megaohm between conductors of mains and submains, and between live and earthed parts of the installation. There are some special cases, for example, sheathed heating elements can be as low as 0.01 megaohms, and other lower values may be allowed if stated in the equipment standard. Now let's look at earthing and bonding and earth fault loop impedance. For earthing and bonding, the continuity must be no more than 0.5 ohms. For earth fault loop impedance, it must be low enough so the protective device disconnects within the required time. For example, 0.4 seconds at 230 volts for subcircuits up to 32 amps. And remember, tables 8.1 and 8.2 give the maximum impedance, ZS values and resistance limits you need to meet for compliance. Common exam mistakes for installation testing include overlooking the 0.01 megaohm special case, only remembering the 30 milliamp RCD trip times and forgetting other ratings, and not knowing the maximum impedance, ZS and resistance values from tables 8.1 and 8.2. Now let's look at 22.2i, capacitors and power factor. A common mistake is thinking capacitors increase motor power or confusing power factor correction with starting capacitors. Another mistake is forgetting that poor power factor causes line losses and higher demand charges. The key point is this: capacitors don't boost motor output. They correct the power factor, reduce line current, improve efficiency, and lower supply losses. Next, let's look at 22.3E reduced voltage starters. A common mistake is mixing up the general advantages and disadvantages of the different starter types. Another issue is that while exams may still say electronic starters are expensive, in reality, VSDs are now much more affordable. Next, let's look at 23.2A single-phase motors. The common mistake here is mixing up which appliances use which type of single-phase motor. For example, some students confuse whether a concrete mixer should use a capacitor start or a capacitor start run motor. These mistakes usually come from not matching the right motor type to the right application. Next, let's look at 25A alternators. The rule is clear. An alternator consists of a stator, armature windings, rotor, field winding or permanent magnets, slip rings, bearings, and housing. The rotor creates a magnetic field which induces alternating voltage in the stator windings when rotated. Common exam mistakes include confusing alternators with DC generators, forgetting that output is AC from the stator, or not naming key parts like slip rings. Next, let's look at 27D lighting principles. The common mistake is mixing up discharge lamps and filament lamps, or forgetting which lamps give poor color rendering, like sodium. Another mistake is not clearly stating the principle of operation for each lamp type. Next, let's look at 27I fluorescent lamp faults. The faults are usually linked to specific components. If the starter fails, the lamp won't start or it just keeps flickering. If the tube is bad, you'll see blackened ends or no strike at all. If the contacts or wiring are loose, the lamp flickers or cuts in and out. If the ballast is faulty, the lamp won't start or overheats. And if the capacitor fails, you'll get poor power factor and higher running current. So each fault has a clear cause and a clear remedy. Next, let's wrap up with the key takeaway for the electrician theory exam. Revise the safety tag rules from ASNZS 4836. Review switchboard requirements, especially men links, signage, and clearance. Practice how test instruments connect and learn the correct installation test limits like insulation, Z's values, and RCD times. Revise capacitor use for power factor correction and know reduced voltage starters, including when to switch over. Apply single-phase motor types to real appliances. Understand the principles of major lamps and link fluorescent faults to starter, tube, contacts, or ballast. These details are where marks are often lost, so keep them sharp. Summary of the 10 errors. Out of the 10 errors, some are quite basic concepts, like connecting test instruments, using reduced voltage starters, or explaining single-phase induction motors. A candidate who scores 90 marks should already know these, but mistakes still happen. The main reason is often the wording of the questions. Tricky or unclear wording can confuse candidates, leading to overthinking or misinterpreting what's being asked. In practice, I would say in a 100-mark exam, about 3 to 5 marks are lost because the wording of the question itself is unclear, especially in multi-choice questions with multiple correct options. 1 mark may be lost if the question itself is wrong or has an incorrect answer. This is very rare, but it can happen. And another 1 mark may be lost if the candidate doesn't have the ASNZS 3000 or electricity safety regulations with them in the exam, since some questions come directly from those references. So in most theory exams, losing around 5 marks is almost unavoidable. Now let's do a quick review quiz covering all 10 errors just to reinforce your study. Take your time, think carefully, and check what you've learned. Good luck for your EWRB exam.